Okay, today we're going to take a look at the Pythagorean identities. Let's go ahead and begin. Students will be able to know the Pythagorean identities. In fact, I'm hoping to show you how to basically derive them, if you will. So here they are. How many properties do they have? Three. So basically, sine and cosine property. Sine squared x plus cosine squared x is equal to 1. I'm going to show you this in a second. And through this one, we can get all, well, not all, but the rest of the two that are left. The next one is tangent and secant. Basically, 1 plus tangent squared x is equal to secant squared x. And then the last one is dealing with cotangent and cosecant. 1 plus cotangent squared x is equal to cosecant squared x. Okay, so let's see how we get the first formula. Okay, so we explored the unit circle, and this is just a triangle right from, let's say, the unit circle, but it doesn't have enough information to tell me really that that's that triangle. What I mean by that is it doesn't say r is equal to 1. So we're not gonna put r as 1. We're just gonna leave it as r in this case. For now, basically. So what I want to do here is this. I want to come up with sine and cosine. So let me change this 30 degrees to just good old-fashioned theta. So if I want to find sine, I would just basically take the opposite over the hypotenuse. So sine theta would be equal to y over r. So far so good? Okay, so now if I wanted to find what y is equal to, I would simply just now multiply r to both sides. When I do that, I get y is equal to r sine theta. Okay, so to find the next one, cosine, I basically do the same thing. So cosine theta is adjacent, which is x, over the hypotenuse, which is r. To find x, I basically multiply both sides by r. That goes to 1. So x is equal to r cosine theta. Okay, so now all I need is the Pythagorean theorem. A squared plus b squared is equal to c squared. Okay, let's plug in all our parts and see what happens. So let's say that I have a squared, which is going to be r sine theta, and I'm going to square it, plus b, which is r cosine theta, and I'm going to square it, is equal to r squared. Okay, so very good shape. If I rewrite this, I get r squared times sine theta squared plus r squared times cosine squared theta is equal to r squared. Let me scroll down just a little baby bit, have a little bit more room. Okay, I can factor out an r squared, so let me do that. R squared times sine squared theta plus cosine squared theta is equal to r squared. Now I can divide both sides by r squared. And so this is how you generate the Pythagorean theorem for sine and cosine, at least the Pythagorean identity, that is. So sine squared theta plus cosine squared theta is equal to 1, because r squared over r squared makes 1. So that's how you come up with the first one. And through this first one, we can come up with the other two. Okay, so that's what we're going to do next. It says find 1 plus tangent squared x is equal to secant squared x, using the formula we just came up with. Alright, no worries. Let me grab Mr. Blue. Now, think about this. If I wanted to get secant squared x, I would basically have to divide everything by cosine. And the reason why, cosine squared x, the reason why is because 1 over cosine squared x makes secant squared x. So I'm going to take my theorem here, my identity that is, and I'm going to divide all the terms by cosine squared x and see what happens here. Well, I basically get here tangent squared x. I get here the number 1 plus 1, and here I get equals secant squared x. You just came up with the second one. Cool. That's it. That's how easy it is to come up with them. So really, you only need to know sine squared x plus cosine squared x equals 1 to get all three, basically. Okay, so this one says find 1 plus cotangent squared x is equal to cosecant squared x, with the sine squared x plus cosine squared x equals 1. Okay, no worries. Now we want to try to get, let me grab Mr. Green, cosecant squared x. That means I would have to divide everything by sine squared x. Sine squared x divided by sine squared x. We're having fun. Divide by sine squared x. If I simplify, that makes 1 plus cotangent squared x is equal to cosecant squared x. So you just came up with the third one. Very nice. Just those teachers that make you memorize them, there's no need in this case. Okay, so let's use this idea now. Okay, it says secant squared theta, secant squared theta minus 1. Now in this case, they just want us to factor the expression. I think they're getting us ready for something bigger, so I don't think we're going to use our identity quite yet. This is a difference of squares. This just makes secant theta plus 1 times the quantity secant theta minus 1. So no identity needed here, but it's coming up, trust me. Okay, looks like they want us to factor another one. The reason why I know I don't need an identity is I have everything in terms of tangent x. So if I didn't, then I might need an identity to make it that way. Okay, so let's see here. I'm going to set up my parentheses. I need basically, let me try this, 4 tangent x times tangent x, and I have 1 plus and 1 minus. This one plus, this one minus. And if I put a 3 here and a 1 here, this should do the trick, but let's double check. If I FOIL this out, I get 4 tangent squared x, and then I get, in terms of the next term, if I multiply, I get plus 4 tangent x minus 3 tangent x minus 3, and so most definitely it does check out, and I do get 4 tangent squared x plus tangent x minus 3. Okay, good, we're in good shape. Okay, example 4. Alright, now we might have to use an identity. The reason being is this. I don't have it all in terms of one trig function. So let's see. I have the formula right here for you. Remember that you can come up with them on your own. So what I want to do here is this. I want to replace cosecant squared x with 1 plus cotangent squared x, and then see what happens. So if I rewrite this, it would look like this. 1 plus cotangent squared x minus cotangent x minus 3. And if I basically add like terms, I get cotangent squared x minus cotangent x minus 2. So now I'm going to try to factor. Because they're all in terms of cotangent, I'm allowed to do that. So cotangent x, two numbers that multiply to make negative 2 and add up to be negative 1 would be 2 times 1. The 2 would have to be negative, and there you go. Looking pretty darn good. Alright, this looks like our final example here. Use the Pythagorean identity to simplify. Okay, so here I've got secant theta and I've got minus tangent squared theta. So I want to put it all in terms of one trig function. Remember that I can just say sine squared theta plus cosine squared theta is equal to 1, and then I can divide to try to create tangent or secant squared theta. Now if I divide everything by cosine squared theta, I get secant squared theta. So this would make tangent squared theta plus 1 is equal to secant squared theta. So it looks to me like all I have to do now is just plug this in and then try to factor if I can. So this makes tangent squared theta plus 1 minus tangent squared theta. And if I combine like terms, wow, I didn't even have to factor this one. I would just basically get positive 1. Okay, let's see if we hit our learning goal. Students will be able to know the Pythagorean identities. I think we took it a little bit further than that. See you in the next video.